All right, so today the plan is to go over. We've got assignment E2, which is for allows us to play with units and delays and some of the more advanced aspects that we've seen implemented inside Vensim and Insight Maker. And then the next assignment, which is our last assignment, and then otherwise your all the other assignments are going to be related to the final project, is this assignment E5, which we'll assign today, but will be due not this Sunday, but the next Sunday. And on Tuesday, the entire class will be focused on just this assignment. And so basically, if you would like help on this, I'm basically going to make attendance totally optional for Tuesday's class. And if you would like help on this assignment, you'll join in the assignment, and then we can work together, sharing our screens, forming breakout rooms, and so on. And if we have time at the end of this class, which I anticipate we will, we can start on that process. And so and then, of course, if we have time at the end of this class, if there's you need help on E2, we can also do that. So this lecture is just outlining this assignment E5, which is my attempt at giving you kind of a template for what a final project might look like. And so I tried to come up with something that it's going to be, it's modeled after the kind of experience at the end of the chapter that we just read. It is complex enough that is sort of the scope and scale that you'd see in a final project. But it's also kind of contrived and like obviously not a very good model, and so it shouldn't compete for your ideas because it's not really a good idea of a model of a city, but it gives you kind of an idea of how such a model would be put together. So that's where we're kind of going with this right now. So after I get done with this lecture, what I've done is I've created 3 breakout rooms, a large room, and then a small room for me helping just on a one-on-one basis, and a small room for Taha, the TA, to help on a one-on-one basis. And so when we get to the end of this lecture, and we'll do the same thing on Tuesday, where Tuesday it'll be all day, or not all day, but all lecture period, where I can help people in general in the large room. And then if people need more individualized help, then we can pop over into one of the individual rooms that you can share your screen with me, and we can take a look and debug. And then once we're done, we can pop back out. And so we'll try to give that a shot. All right, so let's get moving on this then. So the motivation behind this assignment E5 is this comes from this thing that happened at the end of our the last chapter that we just covered, this easyJet example. And I am going to mute everybody's microphones right now, except for mine. And if you need to come off mute to ask a question, then feel free. All right, so the idea here is, if you remember, there was basically a couple of sectors that they ended up modeling. And so there was this easyJet sector where they said, well, how do we model the growth of a company, or the introduction of a company into a market? And so they come up with a basic growth model. So this is kind of the causal loop diagram kind of a growth model. And we can view that as like a sector, and that's just the easyJet sector. But then they created additional sectors. So there's like a rivals sector that was on the side, and they said, well, how do we model the rivals independently of easyJet, just with them connected, loosely by the fares that easyJet has and the fares that the rivals have. And then the last sector, then they have a connection between those two sectors, sectors 1 and 2. And then they created an additional kind of sector, which are these extra complicated processes of, like, even if the rivals weren't there, easyJet would have these limitations on its growth. And so they built these 3 different sectors and kind of connected them together. And this is the causal loop structure for that. But then what was done then in chapter 6 is then they converted those sectors into stock and flow diagrams and then linked them together. And so that's kind of our motivation for what we're going to do in assignment E5. So in assignment E5, we want to create a coupled population and municipal water dynamics model. So you can imagine having 2 sectors here. We're going to have a population sector. And so we know that our population will just start out with this kind of very basic structure that has births and deaths and some population stock. And we know that in this, to make this sector more realistic, we're going to have to add a coordinating network that basically accounts for all of the aspects of the city that would go into affecting things like births and deaths, and how that affects how those are related to the current population growth. And so in the assignment, I basically step through this process of creating this coordinating network, and it's going to force you to exercise with things like a lookup table. So the way the assignment is structured, and we'll see it here at the end here, is that I give you I say I give you a lot of details on how to build this sector up, but then I give you a couple of areas where you get to innovate and come up with your own lookup tables that sort of have to meet certain criteria. So it provides you, in some ways, a little bit of a recipe, but also a little bit of room to play in a sandbox in order to build these models. So we're going to have this first sector, this population sector, and then we're going to have this second sector, water supply. And this is the basic outline of our water supply, where we've got 2 stocks, treated water that is available for use. It then gets used and gets converted over into untreated water. And then that untreated water gets converted back over into treated water. It kind of looks like one of these SIS models from epidemiology: susceptible, infected, susceptible. And if that helps, thinking about that. But then you'll have to add a coordinating network that basically is going to, based on the population that's going to be over here, it's going to affect the water use. And then the water treatment rate is going to affect the amount of water available. And that water availability is going to then come back and affect this population. So together, we're basically got these 2 sectors that you're going to draw, and you're going to draw the connection between them. And so we'll have to link them through their common variables. And so in the assignment, you'll basically build these sectors separately, and then you'll connect them together. And again, the assignment sort of is like a recipe. And you can think of the end product as being something that'll look very similar to the kind of scope and scale that you might expect to see on your final project. So then for those of you who want to get more ambitious in your final projects, then what this also does is then it adds a sort of a bonus and it's bonus credit on the assignment, where you could add additional complicating processes that go beyond the recipe that I've provided in the assignment. So for those of you that want to sort of play around with this, who feel like the assignment kind of was easy enough and you want to kind of go a little farther, then you'll have that opportunity. For those of you that feel like you've kind of gotten enough from the assignment as is, you don't have to go that far, but you can at least read through the bonus to get an idea of where you might go, and maybe you'll go there in your own project. So for example, one of the bonus tasks is to use data from the web to set realistic parameter values. And so in this recipe, we'll say that we'll need to know birth rates and average lifetimes. And you might just pick those out of the air based on your anecdotal information. But one of the bonuses, it will be like, oh, why don't you go to the web and just say, for the average person living in a city under normal conditions, what is the average lifetime? And then so you can then put that into the model in the assignment E5, and then as part of your bonus submission, you can say, where did you get that information? And then it would be great for you to mirror that process when you're doing your final project. So your final project starts out, you come up with a structure, you kind of come up with ballpark numbers from your own personal experience and mental models. But then wherever possible, you go down through and say, can I find a number justified by data that's out there that I can fix on this number that might be different from the number that came out of my head? And if so, can I put that in there and then add a reference in my final report that says, this is where I got these numbers? So that's kind of what I'm hoping to model with this, or pattern for this. So that is a rough outline of what we're getting at here in this assignment E5. And I can bring up the assignment E5 and we'll go through it here at the end too. But what I want to do first is a couple of additional slides which remind us on how to do some of the tasks, like setting up birth rates in Vensim, using lookup tables, and so on. All of these things that you'll have to use inside the assignment. So this is just a review of things that we've already covered, but things that specifically come up in the assignment. But before that, are there any questions so far that I could field? And actually, as just sort of a side thing, because I'd be interested, is there anything anybody would like to share about how your online classes are going in your other courses or in this course? Are there any gripes that you have? Are there things that are happening with, so I see you guys, or I at least virtually see you folks every Tuesday and Thursday, but I'm not seeing any of the faculty who teach the rest of your courses that I normally bump into. So I see it's hard to focus. One of your professors just pre-recording. How do you feel about that? The totally pre-recorded versus the in-person? I'm trying to do kind of the best of both worlds here, but if you guys, I see I like both, that's good. Problems of motivation, I can see that. I think it's hard for faculty too. Haven't watched them yet, yeah, okay. Pre-recorded is helpful. It's difficult to focus and bad connection makes it harder. Yeah, the technology problems, on both of our ends, my end and your end, that's definitely going to be a major barrier. Some people say they would not really like watch pre-recorded. The time slot helps with the schedule. That's kind of my hope here. That's why I haven't pre-recorded these all ahead of time, but I understand that it would be useful for you to have the materials available as soon as possible. But that's what I'm trying to kind of ride that line. Feels like more work than before. I am in my class here, I'm trying my best to stick to the syllabus and then add a little bit more flexibility in some of these due dates. If for some reason it seems like it's overly burdensome more than it was when we were in class, let me know and we can see how we can adjust that. I definitely am sort of frustrated that I see in other classes, people are totally shifting their classes and adding more work or doing different assignments that they weren't planning on doing. And that is not something that I want to do. All right, I see, yeah, much more work and chaos. Yeah, I get that. Yeah, and these group projects. And so I'm hoping that this group project in this class is helpful. I don't really want it to be a major burden. If it is becoming intractable for you to work with your groups, then maybe we can come up with some alternative way to. But I do want to make sure everybody's practicing enough, and so yeah, forget to do the attendance every time. So I may end up looking back over the attendances and adding even more drops. I am not that concerned about attendance. So if anything, it's very likely I'll add more flexibility at the end of the semester for all the attendance stuff. Oh, glad to hear you made a group. So I see some success on the Zoom calls. I think this is a fantastic platform. I use a lot of these different conferencing platforms, and I've been really impressed with Zoom. I mean, it's not perfect, but it is far better than any of the rest. So I definitely encourage you guys to try it out. Okay. Online workspaces just aren't the same and easy. Yes, I can definitely see that. Yeah. People feel very disconnected. Yeah, I mean, if it helps you guys, I before for bandwidth purposes, I've said you can turn off your video and things like that. If it's just helpful to see other people, I just had a faculty meeting yesterday where there were 60 people I think connected, and most of them had their video on, and it was working fine. So if you guys do want to turn on your video, just so you've got a more colorful gallery, and I don't know if you noticed it, but in Zoom, you can kind of force it to exit the full screen, and then you can view the gallery and you can actually see not only the slides but everybody who's looking at the video. If that at least makes it feel more social, feel free to do that. Okay. Oh, and yeah, and I'm glad that you guys, if you need more flexibility, again, I have to make sure that I feel like I'm giving you enough extrinsic motivation. That's the term, but I also really understand this is a weird circumstance, and we're all getting used to it. So just give me that feedback. So let me know as soon as you can if things just aren't quite working out, and we can work on flexibility and things like that. And you know what, like I said, this assignment E5, that's the last assignment we get. If I've put the due date at the normal due date, which is a week from Sunday, but I really don't mind making it due later. But the problem with that is it's going to overlap with all of your, this other group work. And I really just wanted to get this practice out of the way so you guys sort of, felt like you were enabled, that you could start working on your group project. Because the last thing you want to be doing is learning Vensim for an assignment and a group project at the same time. But again, if the deadlines are becoming a problem, just again, give me that feedback, and I can poll the class. And what will the final exam look like? If the things go awry, can the group project act as a final or a mini project? Thanks for the positive feedback there. The final exam, I think, so the final exam was originally going to be a Scantron, and now it's going to be online. So how many people have used Respondus Lockdown Browser? If you want to you can actually use the little buttons. There's a yes button under the participant list, and that would be a nice little informal way to get a poll here. I'm seeing all yeses come in so far. I see one no. All right, so what my plan is to make the final exam on Respondus Lockdown Browser with the monitor turned on. And so what this platform is it basically, it'll take the Scantron exam, which is going to be multiple choice, and I turn it in to it's like a Canvas-based quiz. And I'll give you at least the normal 75 minutes, maybe a little bit more time because of the special circumstances. And the way Respondus works is you download this Respondus browser, and what I'm going to probably do is create a test exam, which will be like 1% of the total exam score, and you'll take that like a week or two ahead of time. It'll just have one question, like it'll be like it'll say like answer yes or something, and you answer yes, but it'll force you to download the browser and try a test quiz. And the way this thing works is it will turn on a video, and it basically video records you, and it uses artificial intelligence to flag anything that looks strange, like if there's people in the background, or if it looks like you're using another resource or whatever. And then it allows me to review those ones that get flagged elsewhere. And that's sort of the substitute for proctoring. And then, yeah, so the cheat sheet sort of thing, then yeah, the goal is to have I want to make the final exactly as I put in the syllabus. And so it'll be a final exam of similar length as originally planned, with the makeup exam as well. So the schedule is exactly what we were planning on doing. So, and then with the same cheat sheet, and all of those. And I may have to be creative about Respondus. It's a little nicer here because there's not that many students. And so if I have to review every video, I can do that. So my hope is to, yes, allow you to have that cheat sheet. And then and then you were just gonna, as one of the questions or something like that, it'll be like to hold up your cheat sheet and then put it down somewhere like within view of the camera or something like that. But in Respondus, you also have to kind of move your video camera around initially to show what the space looks like. And so I'm still figuring things out, but the goal is to basically make it the exact same experience you'd have with a Scantron exam in class, but in the convenience of home. And I have to decide on how we're going to do the time windows, because so I'll probably end up saying like you'll have 24 hours to start the exam, but when you start it, you'll have whatever 100 minutes or something to complete the exam. So that's kind of my plan. Still figuring all that out, but that's roughly what I have kind of in place. There will be an exam day, and during that exam day, you figure out when to start the exam. You take it under lockdown browser with monitor turned on, and there you go. So any other questions about that? I want to try to reduce your anxiety as much as possible. And again, I'm trying to make this almost identical to an in-person, as close as I can to the in-person situation. All right. Okay, great. Well, let's move on. If any other questions or feedback comes up, then please just feel free to bring it up. So, so just a couple of reminders about things that you're going to have to deal with during this assignment E5. So this modeling hint. So in assignment E5, it's going to talk about modeling birth rates for this population. You have to remember that in our system dynamics modeling framework, we have to convert birth rates from the real world into birth rates that somehow act continuously over time. So, so as an example, we in the model, we need to model an average per person birth rate. Now, when you start thinking about how to put those numbers in, you might think to yourself, well, maybe the average number of the average person who has children has 2 children. And so you might be tempted, sir, under average per person birth rate to put the number 2 there. But if you put the number 2 under average per person birth rate, then what you're effectively saying is that they're having 2 children per year. So that would mean, you know, you have to ask yourself, does it make sense for them to have 2 children per year? That would mean that every single year, every individual produces 2 children. And so that's probably not what you meant when you put that 2 in there. And so we have to think about, how do we adjust this birth rate? And so, so yes, that's what this 2 means. Every year, every individual produces 2 children. And so there's a bunch of these things here that just don't quite make sense. And so that's probably not the right model. And I guess I'm going through the, so 2 children for life is not, is too frequent for humans. Humans don't, reproduce every single year, and not every human is reproducing. So how do we come up with a more realistic formula? And so you have to come up with some assumptions. So just like in the SIR model, we said there was a well-mixed assumption that said that population individuals, regardless of if they're susceptible, infectious, or recovered, are going to bump into each other with a rate that is proportional to the proportion of individuals in the population. So they're just bumping into each other randomly, and that was an assumption we made. Well, we need sort of similar assumptions here. So we say, okay, we're going to say that we are going to model this population where we say that humans can't produce offspring by themselves. They have to form some sort of pairs. So again, these are just assumptions we're starting with. There are flaws in this assumption, and we'll get to those flaws. Every pair of humans produces 2 offspring over a lifetime. So already we're seeing that there's potentially going to be a division of the population, because we need a pair in order to produce the offspring. And then there's going to be a further division of the rate, because that pair might on average only produce 2 over a lifetime. Some will produce more, some will produce less. We're modeling the average. And then we need to figure out how long a lifetime is. And so that's where we get 70 years. So we're going to use these, say, 3 assumptions here. Now, of course, there are problems with these assumptions. So sexuality is one problem of this. And so, there's this idea of heterosexual pair formation. Is that really what we want to build a population growth model on? Is there really enough of a population that is going to be producing offspring in order to justify this? And what would be the differences there? I already passed this, but I see a question here that came up. Feel that it's easier to learn Vensim when you're seeing other people who are also working on one of their own. Is there any way we can have a collaborative video chat where we can each see each other's Vensim program? I think here's what we'll do. Once we get to the end of this, and actually on Tuesday, when everybody's here, and the whole purpose of Tuesday is to work on this assignment together. If you feel comfortable sharing your screen, I can enable simultaneous screen share, and we can have people sharing their screens simultaneously in the big group. Or if you like, we can create like 10 different breakout rooms, and we can assign people randomly to breakout rooms, and you can, or even if you'd like to work with certain people, we can figure out some way to do that. And then you can kind of see each other's screens and kind of work on things collaboratively. We'll be able to do, if we have time today, then we can do that for the assignment due this Sunday. Yeah, and then otherwise you're free to, I'm happy with you guys. If you want to work together on your assignments, that's fine, just so long as the work that you're submitting is your own individual work. Like, I don't want you guys to just copy a Vensim model and your Word doc that has all those. I just don't want you to send those around. And actually Canvas will catch that if you do that, if you upload the exact same thing. But if you want to work together on drawing these things together and help debugging each other's problems, I'm all for that. Have your own study halls outside of class. If you think it would be helpful for us to have study sessions outside, then I can see if Taha's got time that he could actually sort of set up, kind of working hours. That would be another thing we could think about doing. All right. So back to the modeling thing here. We have problems with, the pairing assumption. There are also demographic differences in offspring production. So some people might have, if low socioeconomic status might have different production of offspring than high socioeconomic status. Low socioeconomic status might have different average lifetimes than high. And then also, you don't necessarily have one pair that produces offspring for one whole lifetime. You can have multiple pairings. So there's all of these things that add more realism to our model, but we need somewhere to start. And so we are going to call this the whatever. You could call this, if you'd like, and this could be even a negative term, the kind of heteronormative assumption or something like that, of monogamous heteronormative assumptions. And under these monogamous heteronormative well-mixed assumptions, then we come up with a model. And then we could then ask, if we were to add in some of this other stuff, how much would it change our model? And then if it doesn't change it much, then maybe we stick with these ones if we feel like this will be easier to communicate our model to others. So with that in mind, just with these assumptions up here, then we come up with this formula. So we just turn these assumptions into a formula. And so up here, we say that every pair produces 2 offspring. So we just wrote that as 2. So the number 2, that's 2 children per lifetime per pair. And so now we need to figure out, all right, well, how many pairs do we have? Well, that's 1 pair for every 2 people. And then we need to say, all right, well, then how long? So that takes care of the pair. So that will cancel out this pair that's up here. And then we have to say, well, then how long do they live? Well, each lifetime is going to be 70 years. And so that will cancel out this lifetime. And so this formula together, we're going to get to this. So this divided by pair gets multiplied by pair here. And so that pair is going to cancel with that pair. And this divided by lifetime is going to cancel with this lifetime. So these 2 things will cancel. And then we've got, so now we can get this 2 children per person. And then this divided by 70 is going to say per year. So that together, this 2 divided by 2 divided by 70, that will actually be the rate that we will put in for the average per person birth rate. So that's the way in which we can formulate this formula. So if I just do all of that, then I've got 2 divided by 2 divided by 70. And so this is actually the number that we implement. And if you can put all of those units into Vensim, they should all, or Insight Maker, they should all cancel nicely. And it will then help confirm to you that you've got the right formulas, because if you don't have the right divisions and multiplications, then the units won't properly cancel, and Vensim will throw up, or Insight Maker will throw up a flag and say there's something wrong. So then the flow births is just going to be this average per person birth rate times the stock population. And that's how we formulate that flow. So that's what we have there. So any questions on how we form this, and I can go back to the screen here. Any questions on this basic way of how we derive this formula from our assumptions up here? If you just use 2, then you'd have a population that grew way, way too fast. All right. Okay, so let's then look at a couple of old reminders. So in this assignment, you'll have to properly set your DT and your time units. So as a reminder about this time step stuff, then in Vensim, you go under Model, which is a menu up here, and then Settings. And then under Model Settings, you've got this time step, which shows up here, and in there the time bounds tab inside the model settings, and then your units down here. And you generally are going to want your units to be the kind of default unit. So if you notice that every single parameter you're putting into your model is in terms of years, then maybe your unit should also be in terms of years. And your time step is also in terms of these units, but your time step should be much smaller than the kind of smallest time scale that's in your model. And so if, and in some type cases, you're just gonna have to run your models with different time steps, but you might wanna start your time step if you know that the populations grow. I'm not understanding the words to equation part. Can you elaborate on what you mean, Brandy? I don't understand your question. You mean, do you
Yeah.
want me to go back to the equation?
Yes.
Go ahead.
Yes. I'm so sorry. I like chickened out to ask the question when you were on the slide because like you started talking and I was like, oh man, wait, now I lost my chance. But back one
No.
more.
Oh, one more from here?
Yeah, it was like the one where it had all the and you were saying how they cross cancel.
Yes, okay. This one
Yeah, I'm
here?
confused on what I'm looking at, like right now, before the cross canceling. Like, can you say that out loud?
I'm saying, so the one before, you mean,
Yeah,
go
like okay,
over,
you
okay.
said that they're dividing pieces. Are these supposed to be like? Are these like comparison fractions? Like if you were setting up like one of those like conversion? Like are they conversion fractions or?
Yeah, you can add, that's a great way to view it, is you can view these as like conversion ratios. And you're multiplying all these conversion ratios together to get, like, ultimately, we want this average per person birth rate to be, if I go back to a couple of slides, I think I've said the units that I want here. Um, so I want this to be in children per year per person. And so I think I only wrote children per year here, but this is supposed to be per person as well. And so that's ultimately the units that I want. But when I go down through the parameters that I've got here, then I've got this, I have 2 children per lifetime per pair. Well, that's not in the right unit. And then, so I need to convert pair into people. Well, if I multiply this number up here by this one down here, then I can convert this pair into per person because I know that one pair is 2 people. So if by dividing this conversion ratio up top by 2, I'm effectively getting rid of pair and replacing it with people. But then also I need to convert lifetime into years because I need this to be children per person per year. But right now it's children per person per lifetime. Well, I know that a lifetime is 70 years. So in order to get rid of the lifetime, I multiply this ratio here by this other ratio, which is 1 lifetime per 70 years. And so then that will end up making all of these things cancel. And it's a little hard to see because I wrote things out with a division here, and it might be easier if I would have written it out in fraction form. But does that help? And maybe if I go over to the tablet, if I was to write this out, you could imagine, let me see if I can annotate. If I were to write this as 2 children this is per lifetime per pair. So just multiply lifetime pair in the denominator. And then that whole thing gets multiplied by 1 pair per 2 people. And then that whole thing gets multiplied by 1 lifetime per 70 years. And then if you combine all of that, then you end up being able to cancel out the, you can cancel out this pair down here and this lifetime with this pair and this lifetime. And then you get the desired units, which are children per person per year.
Okay, awesome. Thank you so much.
Mm-hmm. Somebody else have any questions here? The notes that I wrote on the side are Zoom annotations. So in a second, they're going to disappear for good. So I want to make sure that I don't clear them until we've cleared out all the questions. So any other questions about this derivation? Great. All right, so I'm going to clear those and keep moving. All right, so we're jumping ahead to the DT stuff. And so just as a reminder, you may need to adjust this time step several times. So you might need to run your model with a small time step and then run it with a smaller time step. And if that smaller time step looks identical to the original small time step, then the small time step was probably okay. As a ballpark, if you notice that people have offspring every, if you think about it, you say, well, there's 1,000 people, and each person has a birth rate of, one offspring every 70 years. Then you could imagine that, well, 1,000 people divided by 70, you could kind of figure out that that's, how many or how long it takes the population to produce an offspring. So like a 1,000 people divided by 70 gives me 14. And so that means that that every year you're going to get 14 offspring with 1,000 people. And so you can kind of flip that around and you can say that, well, so that means that basically every 14th of a year, I get a new reproduction event. And so that probably means that I need my time step to be less than a 14th of a year. So 1 divided by 14 is like 0.07. So maybe I should make my time step, I'll start it out as 0.01. And then I'll run my simulation, and then I'll run it to at like 0.005. And if my simulation looks the same as it did with 0.01, then maybe I just stick with 0.01. So you're going to have to adjust this time step until you find one where things stabilize out. And lower is always better in terms of accuracy, but it is going to make your simulations run slower the smaller that gets. So that's where you change the time step in Vensim. And then in Insight Maker, there's the settings. It's at the top of the model, and it likewise has a time units and a time step, and the same rules apply. So any questions about the time step stuff? All right. All right, so then I think this is one of the last, I think, reminders I have here is then lookup tables. And so you will have to implement lookup tables both in the assignment E2 as well as this one. You'll have to be more creative about your lookup tables in assignment E5. And so let's just, go back into lookup tables. And so we're using this case, this is an example of the fishery. And so even though in Vensim there is a type lookup, the easiest way for you to implement lookup tables right now at this stage of kind of just learning how to do this is to leave the type as auxiliary and change the subtype to with lookup. And so then in the variable where you're implementing the lookup table, you need to wire into the variable. So if I was to draw, this is a variable and this is maybe the regeneration rate. So this is, I'll just say RR is regeneration rate. And you're going to then wire into that variable the thing that you want to be the independent variable in the lookup table. So in this case, it's the fish density. So I can say, fish density, something like this. I'll just fish dense like that. And then that will then show up here because you wired it in. And so then from there, you can then say, well, this fish density that I wired in, I want to make an input to my lookup table. So that's what this top part, this with lookup is. This is whatever you want the independent variable of your lookup table to be, the x-axis of your lookup table to be. So then once you've set that, you can then go to the as graph, and then that allows you to draw your lookup table in. And so whatever you wired in as that independent variable shows up on the x-axis here. So this is your fish density, for example, so density. And so because of that, you should be careful that your x min and your x max are set to values that kind of include all of the possible values that the independent variable could be. So in this case, we know the density is bound between 0 and 1 because it's a ratio. And so we can set this to 0 and 1. And then you can either click on points to draw your lookup table, or you can enter those points in over here in the actual table, and then it will then connect them in Vensim with straight lines. And so if your simulation sees a density in between the 2 points that you've put in, it will then create a regeneration rate that, or whatever the y-axis is supposed to be, it will create a regeneration rate that is in between the 2 points that you put in. So that's how you form the lookup table. And so once you've drawn that out, it will then come back and it'll display all of those points that you put down here in this part of the variable. And then we can do the same thing in Insight Maker, but in Insight Maker, they're called converters. And so you go to add primitive up at the top of Insight Maker, you add a converter down here, creates this green object. And then from there, you can then go through and then linear gives you the Vensim-like behavior. And then this data, this is like where it shows you the lookup table in the text form. But if you go to the little equal sign on the converter, which is when you mouse over it, you get that equal sign, then you can enter points down here, or you can click on points here. And so long as it's set to linear, it'll act like Vensim and it'll connect them. But you can also change it from linear to none, in which case it will then hold those points constant until the next point. And so that gives you a different way to specify different types of lookup tables, where if you wanted to implement this in Vensim, you would actually have to enter points for every corner, and it would connect these corners in a similar way, but you'd have to manually do that. Whereas in Insight Maker, it has this none, which does that for you. But otherwise, the lookup tables look very similar. So are there any questions about the lookup tables? Okay. All right. And just like with that last one, if there are questions that come up and you don't feel like you lost your chance as I move on, just holler and we'll go back. All right, so then reminder, ghost variables. And so in Vensim, you can create aliases to other variables that are on the figure here. And this is really great for connecting sectors together. Because if you have a sector that is, if you have a sector that you've drawn this really nice model up in one side, and you've drawn another sector as a really nice model on another side of your canvas, then you may not want to just create a web of interconnections in between them. You can create ghost variables, which kind of create invisible wires from a variable somewhere on the canvas to a location on another part of the canvas, so that you can end up connecting remote things together without drawing a big wire down through that. And so you go up to the shadow variable, and when you click, I want to add a shadow variable, it shows you all of the variables that you have created, like savings account balance in this case, as well as a few variables that are hidden from you, but that you can access, like the time in the simulation, as well as things like the time step and some other things like that. So the variables you create are already in here. And so if you say you want to create one of these shadow variables, it will then draw it in this kind of lighter colored, and then you can wire from it. And that's identical to wiring from the original thing that it's mirroring. And so in this case, this gives us access to time, which allows us to create things like time varying interest rates. And likewise in Insight Maker, you also have the ability under add primitive. You've got these ghost primitives. And when you add a ghost primitive, it also allows you to select. So basically you can highlight something that you want to create a ghost primitive for, and then you hit that add ghost primitive, and then it ends up creating a copy of that. And it looks just like it, it's just a little bit lighter. And then you can drag this off and put it wherever you want it. And then that helps clean up your diagram. If you've got a big sector on the left and a big sector on the right, and you don't want to draw big wires coming here, you just copy whatever you want to connect to it, and then move that copy over down within the other part of the model. Then you can create local wires, and then you don't need the long wires that go across. All right, so any questions about the ghost variables? Okay. All right. So now time functions. So there, in your final project, there's going to be some people that are going to want to, okay, what are some other ways we can utilize this mirror feature? So really, wherever you feel like it would be useful to have a copy of a variable in one spot without creating a long wire for that. And so that's like really the kind of the whole purpose of this mirror feature. And so it's mainly to just to clean up your diagrams. The downside of that is sometimes it hides interdependencies. So when you actually have one wire going all the way across your diagram, then you can see all the feedback loops, because there might be a feedback loop, a remote feedback loop going way across your diagram and coming back. But if you create these ghost variables, then there's like hidden connections that you don't see there. And so it can be harder to see those hidden connections. So I wouldn't use them a lot, but if you do have these sectors where you have like a tightly integrated sector that just has a few exports to another sector and a few imports from that sector, and it's easy to keep track of them, that's where I would use these. So just to clean up your diagrams. All right, so I think, yeah, I'm pretty sure that this is the last thing that I want to cover here. Because this does come up a lot in your final projects, is that people want to add seasonality to their models. And so the idea here is like, I want to say, what is the effect of the seasons changing on my model? And so I say, well, how do I implement, like, if I were to simulate 10 years of a model, then how do I implement a summer that happens once every year? So how do I get this repeating pattern of, high temperatures, for example? And so you can do that with these time functions that are within Vensim and Insight Maker. And so what's desired is that we want to create a variable that I call cyclic time, that counts up to a certain limit and then resets. And so we want our simulation to run over 12 years, but we want whatever is in this variable to basically be like the month of the year. And so it'll count to 12, it'll reset, it'll count to 12, it'll reset, it'll count to 12, it'll reset, and so on. And if we have this like sawtooth, so that even though time is marching on, is counting continuously up, this cyclic time is counting up to 12 and resetting. If we then run that into, say, our model of seasonality over here, so this could be a lookup table which represents temperatures in the summer, then this allows us to generate patterns that are tied to the time of the year. So let's see more of what I mean by that. So if I create a cyclic time variable, I'll just call, a variable in Insight Maker, then I can go into these time functions. And inside it, I see that the time inside the simulation can be shown in different things, in different units, basically, seconds, minutes, whatever. So I can say, I want to know the time in months. Now this will tell you the time in months since the beginning of the simulation. So if your simulation runs for 4 years, it will count from 0 to 47, or 48, and then stop right at 48. And so the question is, well, how do I get it to count from 0 to 12 and then reset? Well, there is this special function called mod, short for modulo. And I think I probably am jumping the gun here. So time functions, these functions represent time in different units. This is all the stuff that I've already gone over. So months, I already kind of did this. And now I'm at mod. There's this function called modulo. And mod basically is the remainder when you divide by this number. And so if I take this number and let's say it's 11 divided by 12, well, 11, you can't divide 11 by 12. And so you get a 0 out and you get a remainder of 11. And so 11 mod 12 gives you 11 out. But if I divide 13 by 12, well, you can divide 13 by 12, but then you have a remainder of 1. So 13 mod 12 gives you a 1 out. So this is the remainder when dividing by 12. And so even though months will count up to 48, then months mod 12, this expression here, will basically cycle from 0 to 11 and back down to 0. So So that 12 is the number of time units of the cycle before it repeats. 0 being the first value, 11 being the last. And so 0 through 11, that's 12 units. At the instant it would hit 12, it flips right back down to 0. So if our months go up higher than 12, our months mod 12 count to 11, and then they just recycle and continue counting to 11. So that little trick allows us to not only tell us the months, so this gives us the months since we started the sim, this gives us the month of the year. And if we have real numbers here, it also works with real numbers. And so if we've got, 0.5 months since the beginning of the sim, so we've only gone half a month, then months mod 12 also just gives us 0.5. And then likewise, if we've got 12.5 months since the beginning of the sim, months mod 12 will give us 0.5 out. And so with that, we can create a lookup table, and our lookup table only has to be defined from 0 to 12 because the input only goes from 0 to 12. So even though we might simulate for 4 years, which would go up to 48, then every time we hit a multiple of 12, then it resets back down to 0. And then our output of this lookup table might be, let's say, temperature or rain, for example. So maybe this is rain patterns. And so you live in a part of the world where it's rainy in April. So these are your April showers. And then maybe it's not so rainy in December. And so you get this periodic rain pattern where it gets rainy and then not rainy. And then the next year, it'll do the same thing over and over again. And so that's what we're kind of simulating here. And so this is what we're seeing is that this green line down here, this is our cyclic time. And this blue line up here, this is our repeating pattern. So as we go from January to December, then we get a peak in rain in April, and then it falls back down to 0 in December. And that happens over and over again. And then we can do the exact same thing in Vensim. So are there any questions about that in Insight Maker? All right, well, let's then see it in Vensim. So Vensim, in order to, it's only a slight bit more complicated in Vensim. What you want to do is inside your units, inside the model settings, so the time bounds here, you want to make sure that you set this unit to be small enough to capture your repeating phenomena. So for example, I wouldn't want to set the units to, let's say, years if I want something that repeats every month. And so I want to make sure that my units are small enough that it is smaller than the period of the repeating cycle. And so 1 year is too long if I want things to repeat every month, but 1 year is fine if I want things to repeat every 10 years. So, so then what I can do is I can run a shadow variable time into a repeating pattern function. Just so this is sort of, this was all done in one step in Insight Maker, and we kind of had to break it into these two variables here. So we got our shadow variable time into repeating pattern. And then when we look into repeating pattern, there is also a modulo function. And so this modulo function, this is the same thing in Insight Maker where it was like time mod 12, but they just write it differently. They say modulo, and then the first argument is time, and the second argument is the 12, which is like how you want things to repeat. And this will give you the remainder when you divide this time variable, which was the input, by that 12. So here's the input that I wired in. This is my shadow variable. And there it is showing up there inside modulo, and there's the 12. So we're just dividing time by 12 and taking the remainder. And so this would work for a month-to-month pattern. And we can then define a lookup table. So our lookup table only has to go from 0 to 12. So we wire that repeated pattern into our lookup table, and then we can then likewise define this lookup table, which maybe again has a peak in showers in, say, the April months, and then a fall in showers. Maybe there's still some precipitation in December, and then it ends up rising back up again. And so we can end up getting, if I were to plot this thing, so this is my repeating pattern, and so I can see that every year I get the same repeating pattern, and that comes from the lookup table. So that's how you implement seasonality in your models. So that's about the last tip that I have. So are there any questions about that, about implementing seasonality or anything else that I covered? All right. All right, so the announcements looking forward. Continue reading chapter 8 of Moorcroft, which you only have to read up through page 293. And this assignment E5 is, we're announcing today, but it's been available out there, and it's not due this Sunday, it's due the Sunday after next class. And so in the next class on Tuesday, we will spend the entire class. I have no lecture notes provided, and I am not taking attendance that class, but you can come to class. I will be here, Taha will be here, and we will work on this assignment together. And then what's due Sunday, your muddiest point as usual. There's been great feedback. And then this assignment E2, which has already been out there, which is it basically has you experiment with units, sliders, lookup tables, and delays. So next lecture, we've got this assignment E5 we're working on, chapter 8. It's coming up before lecture F1. Between F1 and F2, so then we're going to have you in your groups have this in-class activity where we're basically going to spend the day in class making sure that everybody is at the point where they have a minimal stock and flow model related to their final project. And so what's going to be expected by the end of that class is you to show me or Taha that you've got a simple model that generates results that are related to your project question. It doesn't have to be your whole model, but we want to at least make sure that you've got some momentum going. And then we've got the last two readings down here. So any questions? If not, then before we spend the last 15 minutes of the class with people, working as you'd like, I'll do the attendance exercise. The attendance exercise here is if I were to say 13 mod, so I can even write this in the chat. So the attendance exercise is what is the value of 13 mod 12? And so in other words, what is the modulo of 13 and 12? So if you remember, we defined modulo as something related to division. So if I were to implement in Vensim 13 mod 12, what number would come out of that? So that's your attendance exercise. And so with that, then as you're working on answering that, then I am going to see about potentially setting up these breakout rooms. And if you don't feel like you'd like time and for the rest of the class to work on these assignments, you don't need to hang around. But if you do think that would be helpful, you can hang around and either ask questions in the big group, or we can form these breakout rooms to so that we can get individual help. And so we'll pop into the breakout room for a minute, and you can take a look, and then we can pop back out. So basically, I've just assigned everybody to a big room, breakout room. And when I put everybody in it, then we'll lose this. So the extended session could be recorded, or a session like that at home. I don't, when you mean the extended session, so by extended session, I mean by next class period, I mean on Tuesday. That's when we're, so right now we're just gonna spend 15 minutes, the normal class time. So class normally would end at 4:15. We're just gonna spend the remainder of the class time working on this. And I will keep the recording up so long as it lets me. I think I might have to stop it before I start the breakout rooms. And I thought I did put the attendance question in the chat, but I can put that up there again. What is the value of 13 mod 12? That's the attendance question. And I'll also put the all right, so I think I've got everybody assigned to the big one. And so what I'm going to do now is I am going to, I think, stop the recording for this session, and then I can start a recording in the large room unless anything interesting, just in case something interesting happens in the large room as you guys are asking questions, if those are hanging around. So before I stop the recording there, any big room or any questions in general? All right, so I'm going to just stop the recording here.